Okay, this is Unit 9 review. It is Review C. However, all of our reviews are very similar. So, it won't be the same problems, but it'll be the same type of problem. So if you watch this, you should be able to figure it out. Okay, number 1. Use the following number sets to classify the numbers. Determine all the number sets that the number 2 belongs to. Well, number 2 is a counting number, a natural number. So that means it's going to be everything except for irrational. It is real, rational, integer, whole, natural. So we're going to have 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. It's B. Determine all the number sets that the solution to this belongs to. So we have 4x plus 8 equals 3x minus 9. So we're going to have x equals negative 17. So we have to determine all the number sets that negative 17 belongs to. Negative 17 is an integer. It is not a whole number because wholes are 0 and positives, not a natural. So, and it's not irrational. So now we are going to have 3, 4, 5. So the answer is going to be 3, 4, 5. Determine all the number sets the slope belongs to, so we have to isolate the y. Y equals negative 1/2 x. We can kind of stop there, but I won't. Plus 2. You bring your 4 over, it becomes negative. That's why it's negative 1/2. So my slope is negative 1/2. Negative 1/2 is not an integer because it is a fraction. It's real and rational, so it's 4 and 5. Okay. Now, we need to determine which one is infinite. Infinite never ends. Real numbers equal to 1. I see real numbers, which is always infinite. However, there is an equal sign because the word equal is an equal sign. Natural numbers, which are counting numbers, bigger than 3. That's it. There's infinite number of numbers bigger than 3. I'm going to read all of them just to make sure. Integers between negative 8 and 18. Integers, as you remember, are not fractions or decimals, so that's not it. That's finite. Whole numbers between 1 and 3, that's finite. Okay, so now we need finite. We need something that ends. Integers between 0 and 6, that's it. Okay. Whole numbers bigger than 10, that's infinite. Rational numbers, no equal sign, that's infinite. Real numbers, no equal sign, that's infinite. All right. Onward and upward, kids. Now, we're going to write the following numbers in order from least to greatest. So, you will get your calculator and you will turn these into decimals. 1/2 is 0.5. The square root of 4 is 2. Pi is 3.14. We're just going to use 3.14. And the square root of 2 is, I'm going to go with 1.41. 1.41. Okay? So, from least, from smallest to greatest. The smallest is going to be 0.5. So, 0.5, and I cross that out. The next one is going to be 1.41. Cross that out. My next one is going to be 2, and then I'm going to have 3.14. Smallest to greatest. Now we're going to go from greatest to smallest. So, in my calculator, I go minus square root of 25. That's going to be negative 5. So this becomes negative 5. The square root of 16 is 4. And then I have negative 3.14, and then I have 5. So from biggest to smallest, the biggest one here is 5. Cross it out. Then I have 4. Cross it out. Then I have negative 3.14. Then I have negative 5. Now I need to place these numbers on the number line. Again, I'm going to turn them into decimals or integers, whatever they can be. Negative square root of 4, negative square root of 4 equals negative 2. So this becomes negative 2. Negative 3 stays negative 3. This is negative 3.14. Now, 4 over 5, I'm going to turn that into a decimal. 4 divided by 5 equals, hit my SD, this is 0.8. So this one becomes 0.8. So I'm going to put 0.8 first. It goes about right here. It's between 0 and 1. That's done. Negative 3.14, I'll guess about right there. Negative 3 is easy. It's right here. And then we have negative 2. Now, I would ask that you please label these on the test, but if you get them right, there shouldn't be a question, but please label them. Like go, 0.8. You don't have to label negative 2, it's right there, or negative 3. And then you go 3.14, okay? Okay, 35 divided by 8. That turns into 4.375. 4.375. And then I have negative 2.4. That's already a decimal. The square root of 9 is easy. The square root of 9 is 3. And then negative 0.3. So, here we go. I'm going to put 3 first because I got that one real easy. 4.375, 4.375, maybe right there. Negative 0.3 comes right after the 0, negative 0.3. And then negative 2.4 is almost negative 2.5. Okay, and please label those in the test. Okay, so now we need to simplify the square roots. So I'm going to factor 108. 2 will go into that. And that leaves me with 54. 2 will go into that. And that leaves me with 27. Okay. 3 goes into that. That leaves me with 9. And then 3 and 3. So I have a pair of 2s and a pair of 3s. We're dealing with square root. So 1, 2 is going to come out, 1, 3 is going to come out. That's going to give me 6 square root of 3 for my answer, because this 3 has to stay inside. This, the whole fraction is inside the square root. So that means I have to do the square of 15 and the square root of 144. So I'm going to factor 15, 3, and 5. So that's going to stay square root of 15. Okay? So I know on the top of my fraction, I'm going to have square root of 15. Now, 144, is a perfect square. So I know that. I'm just going to go, because 12 times 12 is 144. So that goes over 12. I'm not going to factor 144. It's a perfect square. Okay, so now we have the square root of 169, which is a perfect square. It's 13. So check in your calculator first. So 169 comes out. It's a perfect square. P to the 16, 16 divided by 2, because it's a square, is 8. So 8 p's come out. S to the 9th, 9 divided by 2 is 4 with 1 remainder. So 4 of those come out, and 1s has to remain inside the square root. Okay, now we have to go the square root of 100. I'm sorry, the square root of 300. 300 is not a perfect square, so I'm going to have to factor that. 2, 150, 2, 75, 5, 15, 3, and 5. So I have a pair of 2's. So 1, 2 can come out. And I have a pair of 5s, so 1, 5 can come out. The 3 has to stay inside. So I have negative 3 over 5 times 2 times 5 times the square root of 3. So this is going to be, I'm just going to use my calculator, negative, oops, well that's 10, so you cancel that out, and that's going to be, I think it's going to be negative 6. That's what I'm going to say. Negative 6 square root of 3. Now, if I want to check my answer, I can put this whole thing into the calculator. Whoops. Three over 5 times the square root of 300 equals negative 6 square root 3. So I can check my answer in the calculator. I cannot do the calculator and then write the answer. I have to see all this work right here, okay? Now, we know 144 is a perfect square. It's 12. So we get 12 over 49. Now we have to reduce that. So in my calculator, I put 12 over 49, hit my equal sign, and it gives me 12 over 49. So my answer is 12 over 49, because there's not a number that goes into both 12 and 49. Now I know that because 49 is 7. 7 can't go into 12. Now we're doing cubed roots. Look at the 3 here. These are no longer square roots, they're cubed roots. So I need the cubed root of 64. That is a perfect cube, that's 4. So 4 is on top of my fraction. And then I need the cubed root of 125. That is also a perfect cube. That's 5, because 5 times 5 times 5 is 125. So my answer is 4 over 5. Now I'm going to check to see if 512 is a perfect cube. I don't believe it is. But I check in my calculator. Oh, it is. It's 8. 512 is a perfect cube of 8. So check in your calculator before you do any factoring. See if it's a perfect. So let me check to see if 216 is a perfect cube. It is. The cube root of 216 is 6. Now I'm not dividing by 2, I'm dividing by 3. So x to the 9th, 9 divided by 3 is 3, so x to the 3rd comes out. 3 divided by 12 is 4, so 4 y's come out. So everything comes out of my cubed root. So now I have the cubed root of 216 equals 6. It's a perfect cube. So I have 6 over 12. 6 over 12 reduces to 1/2. So I check in my calculator to see if they're perfect cubes first. Okay, so the cubed root of 8 is 2. That's a perfect cube. 6 divided by 3 is 2, so 2 A's come out. There we go. Now, I can check these in the calculator, but remember, you have to have, when you're adding and subtracting, you have to have the same inside to be able to add them. I have the same inside, so this is 18 cube root of 30, or square root of 30. But my question is, can the square root of 30 be reduced? So I'm going to go 30, which is 2 times 15, which is 3 times 5. There's no pairs, so the square root of 30 cannot be reduced. Now, we know that these are not the same. This is 5 inside, this is 125. 125 is not a perfect square. So I go 125. Now, 125 divided by 5 gives me 25. Okay. And then this is 5 and 5. So I have a pair of 5s that can come out. So negative 4 square root of 5 minus 2 times 5 is 10 square root of 5. So this gives me negative 14 square root of 5. Okay? Multiplication. We multiply what is out with what is out, what is in with what is in. So 3 times negative 4 is negative 12. Square root 14 times 21 is 294. So we get negative 12 times the square root of 294. So square root of 294 equals not a perfect square. So I have to factor 294 because it can be simplified. 294 is even, so I know 2 will go into it. 294 divided by 2 equals 147. 147 is not even, so I'm just going to try to see if 3 will go into it. It will. 3 and 49. 49 is not even, so I'm going to see if 3 will go into it. It will not. I know 5 won't go into it. 6 isn't prime. Let's go with 7. Oh, yeah, 7 will, right? Because 7 times 7 is 49. So I can pull out 1 7. What is 12 times 7? 12 times 7 is 84. So I get negative 84 square root of 6, because 2 and 3 have to stay inside. Now, if I want to, I can check that answer in the calculator. 3 square root of 14, arrow over, times negative 4 square root of 21, arrow over, equals negative 84 square root of 6. So I was able to check my answer in the calculator. And I just held the calculator up like you can see it. Okay, now let's divide. Negative 30 divided by 36. Negative 30 divided by 36 equals negative 5 over 6. So, negative 5 over 6. 105 divided by 3 equals 35. Square root 35. 5 and 6 cannot reduce, so they stay 5 over 6. Okay, now we're going to solve radicals. I get rid of a square root. Once the square root is alone, I square both sides. X equals 81. My square root is alone because the negative 3 is inside the square root. You guys keep screwing this up. Nothing outside my square root, so I square both sides. X minus 3 equals 36. I add 3. X equals 39. 28. I have 2. This is all inside except for the negative 9, so I divide both sides by negative 9. What is 27 divided by 9? 3. Negative over negative is a positive. So this is the square root of x plus 8 equals positive 3. Now, I have to... Okay, so we have the square root of 8. X plus 8 equals 3. A lot of you guys are just subtracting 8 and thinking that's your answer. You have to square both sides first. X plus 8 equals 9. When I subtract 8, x equals 1. Now, the first thing I have to get rid of is my plus. This is not inside the square root. So I'm going to subtract 8. This gives me negative 4 square root of x equals negative 20. Now I divide both sides by negative 4. The square root of x equals positive 5. I square both of them. X equals 25. Okay, the last one. We have to get rid of the loner first, so I'm going to add 10 to both sides. 7/4 times the square root of x equals 21. Now, I multiply both sides by 4. 21 times 4 is 84. This cancels. 7 times the square root of x equals 84. Now I divide both sides by 7. 84 divided by 7 equals 12. So I have the square root of x equals 12. That's not my answer yet. I have to square this. What's 12 times 12? X equals 144. All right. If you have any questions, remember, bring in your notes. I'll be more than happy to help you if you have your notes. Have a great day. Well, boy.